Hello and namaste. My name is Dr. Amir Sarkota. I'm a professor at the University of Maryland School of Public Health and the principal investigator for AWARD-APR, addressing extreme weather-related diarrheal disease risk in the Asia-Pacific region. AWARD-APR is a multinational consortia involving partners from Nepal, India, Bangladesh, China, Vietnam, Indonesia, Taiwan, Sweden, and the United States. This multinational consortia will develop an early warning system for diarrheal disease in the Asia-Pacific region with a seasonal to subseasonal lead time. We know that warmer temperature promotes bacterial growth, while extreme precipitation helps to spread the bacteria that cause these diseases through contaminated water and fecal-oral route of exposure.
While the overall mortality from diarrheal diseases have gone down significantly, in part due to successful oral rehydration therapy, the morbidity remains high, particularly in the Asia-Pacific region. For example, diarrheal diseases account for over 5% of disability-adjusted life years in India today. Therefore, as the frequency of extreme heat and precipitation events continue to increase in response to climate change, we can anticipate higher burden of diarrheal diseases in these areas. This poses a significant public health threat because not only diarrheal disease increase the risk of morbidity and mortality, it can also pose other serious threats to young children that are undergoing rapid development. Through our collaborative work, we have learned that weather-based warnings do not provide public health professionals enough time to prepare for increased burden of diarrheal diseases that often follow extreme precipitation events such as the 2019 flooding that impacted Kathmandu Valley, shown in this picture. On the other hand, climate-based warnings with a 50 to 100-year lead times are too distant in horizon to have a meaningful discussion about preparedness at present time. What our partners at local and regional level need is a seasonal to subseasonal outlook that provide them enough lead time to prepare for a threat that is within their operational time horizon. We will work diligently with our partners to develop location-specific exposure response function linking extreme precipitation events with diarrheal diseases. We will then apply these exposure response functions along with the seasonal to subseasonal weather outlook, incorporating phases of El Niño southern oscillation to develop an early warning for diarrheal diseases. We will then work with our local partners and stakeholders to disseminate this information to increase community resilience against the threats of climate change.